Artificial intelligence, AI, has long been a fascination. Starring in countless movies and books, AI is depicted from being friendly, helpful to outright evil. What was once mere Hollywood fiction has in part become a reality. Think about it. For many, generative AIs have become integral to everyday life. We use it to create music, write code, make simulations, and design visuals. In fact, the clips you see in this very video were created using AI. Pretty cool, right? But here's where things get complicated. Like with every disruptive technology before, there is a potential for misuse. This is in fact also already a reality. AI-enhanced fully automated weapon systems like the US Air Force's Loyal Wingman can identify, track and prosecute targets with minimal human oversight. According to Paul Lushenko in an article in the Bulletin of the Atomic Scientists, these systems have already been used in armed conflicts, including in Gaza and Ukraine, sparking heated debates about legal, ethical and moral questions. This alone would already be enough to fill an entire video on its own. But in this video, I want to zoom in on the specific topic of AI and its potential misuse in biology. In 2022, former Google chief executive Eric Schmidt warned, "The biggest issue with AI is actually going to be something which we don't talk about very much, which is its use in biological conflict." A recent article in the New York Times states, "AI may save us or construct viruses to kill us." Another article by Vox warns, "ChatGPT could make bioterrorism horrifyingly easy." The list of alarmist takes goes on. It appears that the topic of AI and the risks of its potential misuse in biology provoke very strong opinions. Don't get me wrong, strong opinions are fine as long as they are informed. And therefore, in this video, I want to examine more closely the risks of AI and its potential to reshape the landscape of bioweapons. If you will, this is, in my opinion, a conversation we cannot afford to avoid. To get a more informed understanding of this highly complex and dynamic topic, we first need to understand how bioweapons were obtained in the past before AI. And here we are not talking about small-scale use of infectious agents like contamination of salad bars, but about the development and production of biological agents intended for large-scale warfare. The development, containment and deployment of such weapons have historically required significant resources and expertise. After the First World War, countries like Japan, Great Britain and the United States established bioweapons programs involving hundreds of employees and substantial government funding. One infamous example is the Soviet Union's secret bioweapons program Biopreparat. This large-scale program worked on weaponizing diseases like anthrax, smallpox and drug-resistant plague. Biopreparat highlights the sheer scale and complexity of traditional bioweapons development, which required specialized facilities, highly trained scientists, and an elaborate logistics network for containment, keeping things secret, and potential deployment of biological weapons. If you are interested in the topic, I've made another video on the history of biological warfare, which I will link in the video description. The mentioned endeavors also posed immense risks to those involved. Accidents in containment facilities like the infamous Sverdlovsk anthrax leak in 1979 demonstrate how challenging it was to safely produce and store bioweapons even with substantial resources. Not a small feat even for today's standards. Today, AI is revolutionizing biotechnology. For example, during the COVID-19 pandemic, AI-assisted tools helped identify vaccine candidates within weeks, speeding up global vaccine development. Beyond vaccines, AI accelerates genomics, drug discovery, and even the modeling of complex protein structures. This transformative power is a double-edged sword. So much so that in the same way AI helps researchers, it could also aid malicious actors. Large language models, short LLMs, like ChatGPT, have been shown to inadvertently guide users through complex scientific processes. In 2023, in a classroom experiment at MIT, students were tasked with investigating if AI could assist them in causing a pandemic. In just 1 hour, these non-expert students had successfully used chatbots to come up with suggested pathogens like 1918 H1N1 influenza, enhanced transmission H5N1, smallpox, and Nipah virus, highlighting their pandemic potential and even outlining specific mutations to enhance transmissibility. They provided step-by-step protocols for reverse genetics and even recommended suppliers for synthetic DNA. Moreover, the chatbots flagged companies unlikely to screen DNA orders, even suggesting methods to bypass screening protocols using sequence redesign techniques. Students lacking lab expertise were advised to hire contract research organizations or use core facilities to carry out experiments, essentially outsourcing the technical challenges. In another example, researchers intentionally misused an AI drug discovery model initially designed to identify safe therapeutic molecules. By reversing the model's objective, the AI was tasked with generating molecules that were predicted to be highly toxic. Same model that previously would penalize predicted toxicity now produced over 40,000 toxic molecules within 6 hours, including VX nerve agents, which are among the most toxic known chemical warfare agents. If this shows anything, then how AI tools originally designed for beneficial purposes can easily be repurposed to cause harm. But here is the catch. Knowing a recipe doesn't mean you can actually bake the cake. While AI is capable to guide users through theoretical steps, the practical execution of these methods remains limited by the need for resources, tacit knowledge, and existing regulatory oversight. Recent reports by Rand and others have come to the current conclusion that LLMs have not yet generated explicit, directly actionable instructions on how to create bioweapons, and it is not clear that today's LLMs offer significant advantages over what can already be found on the internet. Personally, it also seems unlikely that outsourcing such endeavors would be possible without creating suspicion and raising questions. So while these steps are far from actually producing a bioweapon, the ease with which AI can democratize access to this information and lower barriers indeed underscores a serious issue. Many media stories paint AI in a light of impending doom. Think about how AI is often compared to nuclear weapons and its potential for devastation. This analogy feels compelling, but falls apart under scrutiny. Developing nuclear weapons required centralized expertise, vast resources, and government-level infrastructure. Bioweapons, by contrast, seem to require less sophisticated infrastructure, earning them the title a poor man's nuclear bomb. But they require something equally challenging I've mentioned before: tacit knowledge. Tacit knowledge is the hands-on expertise, the stuff you can't learn from books or, in this case, AI prompts. Imagine you would try to explain someone to ride a bicycle. Even if you give your best at trying to explain the ins and outs of bicycle riding, it is unlikely that anyone would be able to ride a bike without actual practice. Coming back to biology, for instance, synthesizing a viable pathogen involves mastering hands-on lab techniques, troubleshooting experiments, and handling biohazardous materials safely. You might argue that cloud labs have again lowered this bar. But producing a potent bioweapon at sufficient scale, unnoticed by anyone at this point, still seems unlikely to me. According to experts at the Harvard Kennedy School Belfer Center, even with AI's guidance, most people lack the skills to implement the necessary steps. It's like being handed a manual sports car without knowing how to drive stick. You likely won't even make it out of the driveway. In 2002, scientists recreated the polio virus using publicly available data. It was a groundbreaking yet painstaking process that required years of expertise and a fully equipped laboratory. While this was over 20 years ago, if even trained scientists struggled, it's unlikely that a person without deep knowledge could easily replicate efforts like these today, even with AI's assistance. To state it more bluntly, if the development of bioweapons were so simple, more states and terrorist groups would by now have achieved satisfactory results, which is, as far as we know from historical evidence, not true. Many of the technological advances in life sciences of the last decades have not yet made their way into offensive weapon systems. And until today, biological weapons use has been basic and remains rare. While AI technology has made noticeable breakthroughs in the past, it is questionable whether AI tools available today are as capable as they are often portrayed. The MIT student experiments revealed that while AI could provide information, it often missed critical details. For example, creating certain pathogens requires precursor viruses or advanced cloning techniques that AI tools failed to address. Furthermore, synthetic biology's technical barriers currently remain high, requiring expensive equipment and materials, most of which are heavily monitored already today. Another limitation is detection and prevention. For example, DNA synthesis companies increasingly screen orders against known pathogen sequences. The International Gene Synthesis Consortium (IGSC) has protocols to identify suspicious requests, making it harder for individuals to access essential materials. In addition, biosecurity frameworks like the US BioWatch program, though imperfect, are used to detect and mitigate emerging threats. While current risks often seem overblown, the potential for future misuse of AI is likely genuine, as AI capabilities are evolving rapidly. In a study in Nature, researchers noted that as AI models become more advanced, they could better automate complex tasks, including biological engineering. For instance, future AI might streamline experiments or design pathogens optimized for transmissibility. One chilling scenario involves AI helping create ultra-targeted bioweapons. Imagine a pathogen engineered to affect specific genetic markers, targeting only individuals with a particular ancestry or health condition. While this remains science fiction, it is believed that the convergence of AI and genetic research could make it feasible within decades. So how do we prevent this future? Several measures have been proposed. For example, governments should enforce stricter controls on AI models and synthetic biology tools. For example, pre-release evaluations of AI systems could identify and restrict harmful capabilities. Furthermore, limiting the inclusion of dual-use research in AI training datasets could reduce the risks of misuse. Think of it as removing the recipe pages from an otherwise benign cookbook. Also, expanding DNA synthesis screenings to all providers, not just members of the IGSC, would close critical loopholes. And lastly, strengthening international treaties like the Biological Weapons Convention is essential. Nations must also cooperate on AI safety standards, ensuring malicious actors can't exploit regulatory gaps. But let us return to the opening question. What are the real risks of AI in the development of biological weapons? The answer is, as so often, nuanced. While the immediate risks often seem overstated, the long-term dangers certainly demand our attention. Today, AI might help to look for information, and the information generated is more likely to be of value to malicious actors who aspire to create or use bioweapons. AI's potential for harm lies not in what it can do today, but in what it might enable tomorrow. As AI matures, it will pose further challenges. Balancing innovation with security is an immense global challenge, but it is one we can't afford to ignore already today. Thank you for watching. If you made it this far, then I'd like to say you are amazing. Thank you. I really hope you like this type of content. I certainly do. If you do, consider to like and subscribe to my channel. It would mean a lot to me and also helps to create more content like this in the future. See you soon.